Howdy.
Yeah, I watched yours before I go to sleep. I think I'll see.
Last thing we see. So we were talking about parts of the weld. And these ones this is the other document I was gonna tell you about. This does a really good job of explaining it visually, right? So it talks about face reinforcement, fusion faces and everything else. This one is kind of like your all-around print for a fillet weld. It's great. So face reinforcement, most of you are thinking of typically on a groove weld, but technically it can be in a fillet weld as well. So naturally your face, parts, the toe of the weld, right? These two sections of your leg, this distance, this distance. We know that, but now we're starting to get even more in depth of everything else. So we've got our actual throat. So our actual throat is how far it penetrates in here to where the two members meet. Because remember, this is your root. Right there is your root. There's your prefab root, but here's actually where your weld meets all three pieces. So this is the points where they all three tie together. Okay? So at this point, your actual throat goes from here to the full surface of the weld out here. Okay? However, we know that that's not the case, especially here, it's convex, right? So we go off the leg size, which is the largest isosceles triangle that will fit within it. So that's actually what we call our effective throat. So our actual one is the actual weld. Pretty self-explanatory. Our effective one is how deep did it penetrate? How effective was it into the base metal? Okay? And then also, where's our, this in my theory, this is the actual one that we need to look at. Because when I size my weld, I'm going off my leg size and my isosceles triangle to my root. But my theoretical throat is exactly what an engineer would spec it for, because they don't know how much penetration they're assuming. It just breaks the surface. And I'm going to be honest with you, in a lot of situations, it barely breaks down that surface, right? I mean, it was 70-18 alone. Sometimes it doesn't break that down, you know. So we need that 60-10 to break down that edge. It just barely gets in there. But that's what it's designed for. When the engineer designs it, that's how they design it, is the theoretical throat. Okay? And then you're usually allowed, they'll have a buffers on the, plus or minus 1/16. A lot of times it's plus 1/16 off of the theoretical throat. Okay?
That'll all be determined in the blueprint, right?
Pardon me?
That'll all be determined in the blueprint.
No, not necessarily. It's usually in the job spec, right? So this would be determined in the procedure itself.
Okay.
This would tell you how far your effective throat, your actual throat needs to be. So when we do a fillet weld certification test, you weld to center, you macro etch, you cut an inch off each end, you macro etch it to make sure that you broke down past this section. And sometimes certain codes will tell you that you have to be a 30-second past this line, okay, in order to be there. Other codes, AWS's code just says that you have to see that it broke down this sharp edge, which you can. And if you go in, there's actually a brake test I did, it's in there on the bench. It's broke down and then right in the center I left a section to where it didn't, and you can see that nice sharp edge. And usually you'll be able to see this piece especially is the one you'll see that crisp, clean line on. That's when you know it didn't break it down.
Where's that in the shop?
It's in the shop, yeah. And so in that case, that's how you do a certification for a fillet weld, right? Which is a very popular one, especially for iron workers. You'd be able to do this, especially if you're doing a lot of the iron beams and I-beams and so forth. You're not doing a ton of square weld or B-groove welds. You're doing a lot of fillet welds, heavy fillet welds, inch and a half or so. But a couple things is this weld interface is basically, the interface is where the heat affected zone ties into the base metal, right? So you need to start looking at which one's the weld interface, and then here's your filler, your penetration or your fusion zone is exactly just that. And this one's self-explanatory. Depth of fusion is also your fusion zone in this case. So in looking at a fillet weld, the first two things I decide are what? Is it convex or concave? That tells me two things. It tells me which way I'm going to measure it. If it's convex, I measure it off of my leg size from toe to toe. Right? If it's concave, Then I look at my actual throat size. Because if it goes in this direction, now my effective throat is down here, right? Even if my leg comes up here. So at this point, it actually would be good. Let me just do a quick drawing of it real quick, just so we can see it. Convex weld. Our theoretical throat is from here to here, well, wherever it can appear. Okay. And that's, at this point, we're gonna measure off of, with this weld gauge to determine size, call it 1/2 inch. This one here, so this is very similar to 60-10. This is also very popular with flux core welds. A lot of flux core welds I see, especially on a vertical progression, end up being very concave as well. Okay? So looking at this, there's actually the throat dimension. And if we went off leg to leg, this might be 3/4 of an inch, but the weld size is actually only 1/4, so this is your weak point right here, right? Actually, in this case, it ends up being right along this edge here, okay? So those are the first two ways I decide how I'm gonna weld, measure that weld, convex or concave. It's also what I know the inspector's gonna look for from the welding perspective too. You know, I know it needs to be at least flush, slightly convex, right? Perfect. Here's the other one, talks about root opening, root face, bevel angle, breaks it all down for you, okay? Couple of things that I will say here. Well, I'm going to come back to this, because we just did the fillet weld one. I want to make sure that we look at the groove weld parts of the weld first, okay? So now in this case, we've got face. This is still the face of our weld, and this is the root of our weld. But however, the reinforcement is the amount of distance from the actual plate to here. So when we measure this weld, the other thing we don't do is we don't measure the entire, the other one we actually had an actual throat, right? With fillet weld size, there was actually an actual throat. With a groove weld, there's not. Your weld size is never bigger than your plate. And this is why I'm always also very specific about, make sure you don't grind that plate out here. Or if you blend grind this down, a lot of people actually take the chance of actually dishing this out when you're doing that, okay? Which now you've created the opposite issue. We want to leave just a small amount of material here, just right above that weld size. So if this is 1 inch thick plate, what's the maximum size of this weld?
1 inch.
1 inch. Even if it's got an 1/8 inch reinforcement, still a 1 inch weld, okay? And actually in AWS code, you're allowed up to 3/16 on 1 inch, but it's still called a 1 inch weld, right? So when they say, when you see on the print, 1 inch weld, and you see that it's prepped as a 1 inch weld, you know, it's complete joint penetration, but you're also allowed 3/16 of an inch leniency. So see how knowing these codes help you as a welder say, oh, I can go quite a bit more. I don't want to take a chance of getting undercut. 64th of undercut will put me down the road. But if I'm 1/8 of an inch above, I'll be fine all day long. Okay? Fusion face, again, this is non-welded. This is considered the fusion face. As soon as it's welded, it now becomes the groove face. Okay? They're the same thing. Alright? Depth of fusion, exactly what it says. If you notice the weld interface, where the heat affected zone and the grain structure ties into the base metal. So I'm sorry, it's not the heat affected zone, it's actually where the weld has changed the metallurgy. The heat affected zone can be out here even further as well, because it's very hot, okay? And we'll get into that in chapter 8 of metallurgy. The root. So we have the root penetration, but you've actually got the two edges where the two pieces meet are actually considered to be your root as well, okay? Root reinforcement usually has a speck of an 1/8 inch or so too. Alright? Read through these, you know where it's at. But let's get back here to this one real quick. We talked about weld size, number 7, plate thickness, And in a groove weld, it's the exact same as the actual weld size. Root opening, and then 2 is your root face, most commonly referred to as your land. 3 is your groove face, bevel, angle, included angle, and so forth. All right? Sounds good. Glad everybody's on the same page. All right. I thought that one did a much better job of breaking it down instead of just this one, so I'm going to go past that. Here's some flange welds. Again, depending on what you're running and what you're welding, these can be very common. Here's your initial. Again, you do see that when I first started welding, I thought, oh, I'm just going to do pipe or plate. I'm never going to see any of this stuff. Well, this is square tubing. I've seen a ton of it. And it took me a long time to realize, oh, that's just square tubing tied onto an I-beam, right? Something like that. There's a lot of stuff out there that's going into the square tubing world. Okay. Parts of the weld, kind of talked about those for the most part. Toe face reinforcement, blah, blah, blah. There's another one, kind of shows a little different section. Wow. So here's where we start to get very critical, right? Oh yeah, it's just a root. This is just a root, right? Is that what we're looking at? Is that's the root weld?
Yeah.
Exactly. And that's exactly the difference in how we know it. Without us spelling it out and telling us that it is a back weld, we know that's a back weld. If this was the root, this black line right here wouldn't be there. This would show this is one solid weld to where it was all welding from the top side alone. However, when you get into, like, especially widgets, they're really particular about the heating and the distortion within them. So in this case here, you can tell that this weld was put in after this weld. So this is now a back weld. So the difference between back or backing makes a huge difference. Backing is exactly what it says. It's the first one. You're going to use it as backing. So I want you to think of the backing strip when you did your other plates, right? Your backing strip was put on first, and then you weld the top of it and adhere it to it. Back weld is the exact opposite. The back weld means that you come around after you're done, you come back and weld the other side after you've welded from the one direction. So from this picture alone, I can tell that's a back weld, not the root weld. So in this case, my root is now right here. My root is no longer here on these edges of this plate. My root is exactly right here now where these two welds join together. Okay?
So it'd be essentially flipping it over and welding it, right?
Absolutely. Yeah. Heavy, thick iron, 70-18 only, absolutely. We used to do this all day long on construction. You weld it, and then you turn around, you air arc the backside out real quick, and then you back weld it up, right? So you air arc any slag or impurities or the crap out of it, where it's down to clean white metal, and then you fill it back up. All right. And we looked at the fillet weld, everything was going good there. Joint and root penetration pieces. Okay. It's exactly pretty much what we're talking about. Sorry, I'm going to try to adjust this just a little bit. All right. So we talked earlier about incomplete joint penetration, complete joint penetration. Again, complete joint would have been this one. Particularly, well, either way, even if it's a back weld, it does penetrate the entire weld joint, okay? So this is a complete joint penetration. On the print you see it's a CJP, okay? This is an incomplete joint penetration. We talked a little bit about 10 inches of steel. Maybe this is only the top 1 inch of this prep, okay? However, there are certain times that you're going to see the opposite of this. So instead it goes back to the J groove, it will be a V groove like this, but they're going to say that the root penetration needs to be full length or full weld size. Sometimes is how they'll call that, right? So this might be, sometimes I'll leave it up to you to to look at it, so I know what's the hottest I can get and penetrate with 7/18 1/8 inch. Usually I set mine at 1/8 of an inch. So just like I were doing my square boot, my bead groove plates in the shop, I set my land at an 1/8 inch with 60/10. And in that case, I would know that this joint penetration needed to come all the way through, okay? Certain times it doesn't have to. I've never really welded on a lot of these, to be honest with you. That are speccing a lot of differences this way. They usually just tell you that the weld size, it's either gonna be like a 2 or 3 inch thick material, and they're gonna say you need to have a weld that penetrates roughly 7/18 electrode, no prep, anything else, just weld all the way around as an edge weld. It's usually what I've seen. Very seldom have I seen a ton of this go very deep. It's usually 1 or 2 weld surface, 1/4 of an inch max, okay? We hit this up earlier, okay? There's not a ton here other than a weld joint spacer, which we talked a little bit about. Sometimes it can be a consumable insert, sometimes it's just a spacer. It can be a ceramic spacer sometimes too, right? So particularly for stainless or something to eliminate some back purge. Imagine a 6-foot or a 10-foot tank, right? Or a brewery tank. Let's take a brewery tank to start with. Right? Now they've got some pretty cool pickling paste and some other tape and ceramics and stuff. But you used to be able to take a joint spacer and put it in there, and you can weld over that stainless, and the shielding gas from your torch is also used as your back purge, right? Or it's set in there on a ceramic or a copper piece, and then you can come back from the inside and actually do the same thing to where you don't have to fill that entire tank full of argon as a back purge. I mean, that would be $10,000 worth of wasted material or more if you had to purge that tank and then weld 50-some feet around that tank at one time. So that's how we keep our costs down, particularly on certain situations like that. All right. Again, we can look at this one, weld base metal. Here we are again. We know this is now a back weld at that point because we can see that root instead of being one solid weld. Okay. Here's an incomplete joint penetration from both sides. You don't see this a lot, but every once in a while you do. I have seen this on some larger chain, like drag chain, heavier stuff for mining, big, heavy mining industry. Not necessarily going to hold something up, but just pulling something towards it, right? Cable or something else. It needs to be 1 inch deep on both sides, and it's 4 inches or 2.5 inches thick. It doesn't say it has to be complete joint penetration. So your E, which is the thickness, can never be less than the base metal thickness as well. So your full penetration naturally goes back to the same thing. If you've got a 1 inch weld, these two welds cannot together be greater. The sum of them cannot be greater than 1 inch at that point, right? No matter what, they have to be 1 inch. Here was what we drew on the board earlier, concave, convex fillet welds. Please walk you through it again, you can always reference these. Sequencing of welding beads. Here's where we're going to talk a little bit more